Welcome back to ajspeller.com. In today's tutorial, we're working on a related rates problem. The radius r of a sphere is increasing at a rate of 2 inches per minute. Find the rate of change of the surface area when the radius is 6 inches, 12 inches, and 24 inches. We always begin these problems with a sketch. So here we're going to draw in a circle, and then we're going to add an equator here so that we can make this into a sphere. That's the visible side. On the back side, we're going to draw a dash equator for the invisible side, or the side not visible from the front here. Place a dot here in the center, and then we're going to draw a radius. From the problem here, we know that the radius is increasing at a rate of 2 inches per minute. So, well, first let's label this r, and we know that the change in the radius over time is 2 inches per minute. Next, we're trying to find the rate of change of the surface area. Well, the formula for surface area, which we'll abbreviate as SA, is equal to 4 pi r squared. And to figure out its change over time, we have to differentiate with respect to time. So here we're going to end up with dSA over dt is equal to, well, 4 pi is a number, so that comes out front. And we take the derivative of r squared, which is 2r. And because we're differentiating with respect to time, we have to add on the factor of dr dt. So dr dt. And now let's simplify some of this. We have 4 times 2 to give us 8. We multiply our factor of pi. We have the radius, and then we have the rate at which the radius is changing. So the expression that we're going to use to figure out the change of the surface area over time is 8 times pi times r times the rate at which r is changing. And also notice here that we have 3 different snapshots. The first snapshot is when we're at 6 inches, 12 inches, and then 24 inches. All right, let's start off when r is 6. And let's place in our unit 6 inches. Well, we know that dSA over dt, I'm going to use this expression down here. Well, we have 8 pi times the radius. Well, the radius is 6 inches. And we're going to multiply that times dr dt, which is 2 inches per minute. So here I write in the 2 inches per minute. And again, it's understood that everything here is over 1. Alright, then I just multiply straight across. I have 8 times 6 times 2. Well, that there is going to turn out to be 96. Then I multiply by the factor of pi. Then on my units, inches times inches gives me inches squared. And then I multiply 1 times minutes to get minutes. So here we see that at the moment the radius is 6 inches, the surface area is changing at the rate of 96 pi inches squared per minute. Alright, let's move on to our next snapshot here where r is 12. And I'm going to leave off the units for speed. So I have dSA over dt is equal to 8 pi. Well, this time the radius is 12. Our rate of change is still going to be 2. And we end up with 8 times 12 times 2. Well, that there turns out to be 192. Multiply by the factor of pi. And I already know that my units are going to be inches squared per minute based off of what we've seen in the first example here. So what this means is as the moment at which the radius is 12 inches, we know the surface area is changing at 192 pi inches squared per minute. And then let's move on to our last snapshot here where r is equal to 24. Again, we have dSA over dt, 8 pi times the radius r, well, the radius is 24, times the rate of change of the radius, which we see here is 2. And then we're going to go ahead and multiply all this out. So we end up with 8 times 24 times 2, and that turns out to be 384. And again, we have the factor of pi, and then our units, inches squared per minute. And again, what this means is that at the moment that the radius is 24 inches, the surface area is increasing at a rate of 384 pi inches squared per minute. Alright, well, that sums up this tutorial by ajspeller.com. And as always, thank you for watching.